maths for me and you. Let's learn maths together. Topic discussing in this video is how to find HCF using Euclid's division algorithm. Euclid's lemma. Given positive integers a and b, there exist unique integers q and r satisfying a equals bq plus r. 0 less than or equal to r less than b. The meaning is, if we get two numbers we can divide and we can write them connecting with the quotient and remainder. Q and r means quotient and remainder respectively. What is algorithm and lemma? We can see. Algorithm means it is a series of well-defined steps to solve a problem. That means we write many steps to get the answer. This is algorithm. Next is lemma. Lemma is a proven statement used to prove another statement. That means it's already a proved statement and we use it to prove another question or another statement by writing many steps. Now we're going to find the HCF of the following set of numbers. 3 questions are given below. Find the HCF of 135 and 225 is our first question. To find HCF, we will divide the big number 225 with 135, then write with quotient and remainder. So 225 is equal to, we are going to write connecting with the quotient and remainder. For that, we will take 225, then divide with 135 and look what is the remainder we get. So 225 divide with 135. When we look, it goes only one time. So 135 times 1, 135. And then subtract, get the remainder. What is the remainder here? We get the remainder is 90. So 90 is the remainder. Here we will use Euclid's lemma and write the result. 225, when we divide with 135, we get quotient 1 and the remainder 90. Again, we need to continue this division process. That is algorithm. Write many steps. And how to continue? This time we should start with 135 and divide with the remainder 90. So we will write 135 is equal to, and we are going to divide by 90. So 90, and then we will write 90 times what number and what remainder we are getting. 90 times a number we will get and a remainder also we will get when we divide 135 with 90. How many times it goes? Only one time, because if we take 2 times, 90 times 2 is 180 and it's larger number, so it only goes one time. And what is the remainder gets? We get the remainder 45. We can write the result again using the lemma. When we take 135 divide by 90, then quotient is 1 and the remainder is 45. 90 times 1 plus 45. Continue the steps until we get the remainder 0. So this time we should start with 90. And what we will take for dividing? Dividing we will take 45. 90 we divide by 45 and look what remainder we get. Take 90, divide by 45, and as we know it is 2 times 45 is 90. 90 minus 90 is 0. See, here we are getting the remainder 0. 45 times 2 and then the remainder 0. That means we can stop this process. Here we get HCF. What is the HCF? HCF is 45. So HCF of the given two numbers is 45. In the next question, we have to find the HCF of 196 and 38,220. We do the same process. Start with the larger number 38,220. We use Euclid's lemma, divide and find the quotient and remainder. What number we will use for dividing 196? The second number. So the larger number 38,220 divide with 196. 38,220, it's a large number. So we will take step by step division. First we will take 3 digits 382 because the first digit 3 small, 838 small, 382. Okay, we can divide. And how many times goes? 1 time. 382 we take, and 1 times 96, 196 is 196. What is the remainder? It is 186. Next digit is 2. We will bring down 2. So the new number is 1862. Again we divide with 196 and then it 9 times. 1764. Subtract to get the balance. Here the balance we get 98. So the next digit 0 comes down. 980. 196 times 5 is 980. Here the remainder we get 0. Now write the result. The given number 38,220, when we divide with 196 we get 195 as quotient and 0 as the remainder. We can write 196 times 195 plus 0. When 0 is the remainder, stop division and we can write what is HCF. HCF is 196. So HCF of the given two numbers is 196. Next is a similar type of question, but it has a second part also to be proved. And the question is, find the HCF of 81 and 237. We know that how to find HCF. And the second part is, express it as a linear combination of 81 and 237. That is, we have to write the HCF is equal to 237 times x plus 81 times y. Let's see how to do it. First, the two numbers we will take and start with the larger number 237. Divide with 81 and look what is the quotient and remainder we are getting. So 237 divided by 81 and it is 2 times, then the result is 162. The remainder we get is 75. 81 times 2 plus 75. 237 is equal to 81 times 2 plus 75. Here we look what is the divisor. It is 81 and what is the remainder? 75. Next step we will start with 81. 81 is equal to, then divide with the 75 and get the quotient as well as get the remainder. Divide by 75 and we can write it is 75 times a number plus remainder using Euclid's lemma. 81 the number, divide with 75 just one time, 75 times 1 75, and what is the remainder we get? It is 6. We can write the result 75 times 1 plus 6. Next step we write 75 is equal to, because the remainder is 6. What time we will stop this division process? Until we get the remainder 0 we need to continue. That means when we get the remainder 0 we will stop. So here we write 75 is equal to 6 times a number plus remainder. Take 75 and divide by 6. I'm using step-by-step division because 2 digits and 7 is a larger number than 6. So we write 1 times 6 is 6, balance is 1. Next digit 5 comes down, 15. 6 times 2, 12, and the balance is 3. So we get the remainder 3. 6 times 12 and the remainder 3. Write the result. 75 is equal to 6 times 12 plus 3. Again we need to continue division. Why? Because of the remainder 3. We have to continue the process until we get the remainder 0. So we continue. Now we take 6 and take the remainder to divide. But we know what is 6. It is 3 times 2 plus 0 the remainder. When we get 0 as remainder, stop. And here is the HCF. HCF of the given two numbers is equal to 3. And what are the given numbers? 237 and 81. So HCF is 3. But don't forget there is a second part also to be answered. And the second part, to get the second part, what is the second part? Second part of this question is we have to write the HCF as a linear combination of the given two numbers 237 and 81. How to write? 3 is equal to 237 times x plus 81 times y. To get this linear expansion, we will use the division step which already we have done for finding HCF. So you can see we need 3 on the left side. We will use the step 75 equals 6 times 12 plus 3. And how we get 3? 75 minus 6 times 12. Just above that we can see it is 6 plus, so we can replace 6 and find the value in terms of 81. 75, the first term same, minus only we replace 6 using the just above step. It is 81 minus 75 times 1 means it is 75. So 81 minus 75, outside is 12 times 12. Now open the bracket by multiplying with the 12. 75 minus, now open the bracket, we get 81 times 12. Minus times minus become positive, 75 times 12. Now we can see 75 times 1 first term and 75 times 12 the last term. Together it is 75 times 13. 1 plus 12, 13. Minus 81 times 12, same we write. Now keep 81 same because we need that in the expansion. And we change 75 using the first step in the division. 75 we can write in one side, and 237 minus 81 times 2 we write in place of 75. 75 we change as 237 minus 81 times 2. Then times 13 right outside. This is just 75, so times 13 right outside, minus 81 times 12 right same. The bracket we can open. How? By multiplying with 13. 237 then times 13. Next is minus 81 times 2 times 13 is minus 81 times 26. 13 times 2 is 26. Last term same, minus 81 times 12. So there are two 81 terms, negative 81 two terms, and we combine in the next step. 237 times 13 right same. Next we combine minus 81 terms, minus 81 and 26 and 12. So together 26 plus 12, 38. Minus 81 times 38. Then we don't need negative in the middle. See the question, we need to write the expansion with the positive 81. We are going to change that. 237 times 13 plus 81 and give that minus to the number 38. So it becomes times minus 38. This is the linear expansion we need for the HCF 3. We can write 3 is equal to 237 times 13 plus 81 times minus 38. And in place of x, we can see the number 13. 237 times x, and in place of y the number is minus 38, that is 81 times y. 81y means y is minus 38. So we have expressed 3 as a linear combination of 237 and 81. 237 times x plus 81y. This is the proof for the second part.